I'm Jamie Griffin with the TxDOT's Bridge Division. I'm going to go through, as Mary Ellen said, some of the individual elements that make up the historic bridge toolkits. Now, these toolkits are going to be a really great reference. It's going to help our bridge owners maintain their historic bridges and address some common problems. The guides are designed to be used by anyone from TxDOT personnel to state, county, or local officials, regardless of the level of bridge experience. And to that end, the toolkits are going to begin with a visual glossary that provides visual depictions and some basic bridge terminology. As you can see here, we've got a basic truss diagram here with all the little members labeled. We also provide some different types of truss bridges and the different types of truss bridge connections. Each term in the glossary is going to be presented with a clear picture of the bridge element, its location either on the superstructure or the substructure, and a brief description. We've also included some of the elements of the truss itself, such as the diagonals you can see in the photo there, as well as some substructure items like footings and roadway items such as embankments. Now, the glossary also includes definitions for some of the potential problems you might encounter, such as scour, which you can see in the bottom left there. Now, with these definitions, the bridge owners are going to be able to more clearly identify the problems that are going to be described later in the maintenance tables. Now, as Mary Ellen mentioned, these maintenance tables are divided into easy-to-read sections based on common events that might necessitate a repair. I'm going to go through each of the tables individually and provide a few examples for each one. Okay, the first thing we're going to talk about is a really common problem, and that's impact damage. This, excuse me. Here you can see the maintenance table that describes actions to undertake after impact damage. As with the visual glossary, the information is presented in a clear, concise manner that includes a verbal description of the problem, suggestions for actions that the owner should or should not do, as well as images illustrating the problem. For example, after an impact, you may observe dented or bent truss members, as you can see in the photo at right. In this case, the appropriate action is to notify a structural engineer. The engineer can evaluate the damage and determine whether or not the bridge is safe to remain open. The owner should not, however, attempt to straighten the member, as this can likely exacerbate the damage. Because these bridges are fracture critical, which is to say they lack redundancy, every element in the bridge is going to be crucial to the structural stability of the bridge. So whatever repairs you make to these elements need to be made with the utmost caution. All straightening has a potential to damage steel members by altering the material properties of the member, which can make the section either weaker or more brittle. And of course, that will affect your load carrying capacity. Now, another action that owners should not take to repair damage is going to be welding. While damaged members can be repaired by removing the deformed section and replacing it with a welded-in section, these repairs have an even greater potential for causing more harm than good. Problems can include undercut welds, which is going to reduce the section of the attached member, and as with straightening, you can also alter the material properties, which will affect your load carrying capacity. In addition to that, the steel that makes up historic bridges is much higher in carbon content than a more modern steel bridge, and so welding gets very, very tricky. Your welder is going to need to pay careful attention to control his temperatures in order to achieve a quality weld. So any of those welds really need to be undertaken by a certified, experienced welder and examined by a structural steel inspector. Another common problem with impact damage is going to be cracked truss members. You'll typically see this problem at a connection where resistance of the connection has caused a failure of the connected member. Now, actions for this type of damage is going to be similar to those for dented or bent members. The damage just really needs to be evaluated by a structural engineer so that you can verify that the bridge is safe to remain open. Now, the next table is going to describe another common source of damage to historic, or well, really any bridge, and that's flooding. Here, the maintenance tables are going to address erosion, substructure stability, and debris accumulation. For example, if the owner observes erosion around elements of the substructure, there are several actions that can be taken depending on the location of the erosion. As you can see here at the abutment, you can add riprap to stabilize the embankments, which will help to prevent further erosion. However, if you have erosion that's below the existing at-grade line, you need to refer that to a structural engineer so that they can make sure that the stability of the substructure hasn't been compromised. Actions that could be harmful would include building berms upstream of the bridge, as this can trap debris and result in further damage, or backfilling erosion that you have that's below, again, below the existing grade. If you backfill, you can potentially conceal the problem, or maybe even create more erosion. Along the same lines, instability of the substructure that's usually caused by scour or erosion always needs to be referred to a structural engineer. Owners should not attempt to repair the problem themselves by backfilling or by adding additional members to the substructure to try and improve stability. Now, the next maintenance table we're going to talk about is vandalism. This is a very common occurrence, as you can see on Mary Ellen's slide with the nice little heart that was painted on it. But vandalism can include anything from setting fire to the bridge, which has actually happened. We have a lot of wood decks, and so when people go to have a bonfire on the bridge, that can happen. Yeah, it has. And also, you can get tagging on the bridge elements or on the load posting signs. Okay, so starting off with fire damage, and again, see, it has happened, there's a picture. With fire damage, again, this one really needs to be referred to a structural engineer. And the reason for this is kind of like with welding or straightening, the heat from the fire can actually alter the material properties of the nearby steel members, which will affect its load carrying capacity. So again, if you have a fire on your bridge, you really need to have this evaluated by a structural engineer to make sure that it's safe to continue to use the bridge. Tagging is another extremely common problem on both the truss members and the load posting signs. Now, if you're trying to remove a graffiti from the bridge itself, all you need to do is just, the owner can overpaint that, do a quick spot paint over it with a color, or with a paint color that's going to match the color of the bridge. If you have a tagged load posting sign, that's pretty easy to correct. You can always just request a new one. That's going to bring us to the last maintenance table here, which is going to discuss actions you need to take following a bridge inspection. And because these bridges are fracture critical, they're going to be subject to an inspection at minimum every 2 years. And these inspections can turn up a wide variety of problems, from damaged or corroded truss members to packed deck joints, and excessive vegetation or missing load posting signs. Okay. A common example of corroded or damaged members, especially on unrestored bridges, is pack rust. Pack rust forms between two connected members, typically at the cover plates and at the connections. Now, as the pack rust forms, it expands, which can result in severely deformed members, as you can see in the photo. Here, the pack rust formed between the rivets and expanded out that cover plate that you see to create that kind of wavy pattern that you see on those members. Now, as with most problems uncovered during an inspection, these problems really need to be evaluated by a structural engineer. Whenever you have pack rust, you've lost section on that member, and when you lose section, you lose load carrying capacity. So this needs to be checked just to make sure that you have enough reserve capacity to carry the loads that the bridge is going to see. Another extremely common problem with older bridges is going to be at the joints. The joint between the different elements of the deck is going to fill, or can often fill with debris. When it fills with debris, it's going to expand the deck, which can result in a lot of damage to your substructure. We've seen cracked or displaced abutments, bent or rocked over truss bearings due to these packed-in joints. Now, this can be a particular problem with off-system bridges where you might have dirt or gravel approach roadways. As a vehicle drives across the dirt or gravel, that debris accumulates in the tire, which will then be deposited in the on the deck and eventually accumulate in these joints, which, like I said, can expand the joint, which can lead to damage to your substructure. One of the best impacts that a owner can have on extending the service life of the bridge is going to be cleaning out those impacted joints. If you keep those joints regularly cleaned out, you're not going to develop enough debris in there to expand the joint and cause damage to your substructure. Another very common problem is excessive vegetation on the bridge. And while it really looks nice, unfortunately it holds a lot of moisture right up next to the bridge members, which is going to lead to corrosion. So if you keep that vegetation cleaned off of the bridge, it's going to go a long way to help prevent costly repairs in the future. Now lastly, we've included some suggestions for routine maintenance. That's going to include stuff like patching your concrete decks, removing vegetation, and cleaning out the connections. Now, just like with the bridge joints, your connections are going to accumulate a lot of debris from flooding or just from general roadway debris. Because these connections are usually 2 gusset plates, they're kind of confined, and so when the debris gets in there, it's really hard to get it out just through normal raining or washing out. So a really quick solution that's going to end up saving the owner a lot of money in the long run is to go ahead and clean those things out with a high-pressure water spray. That'll just wash all the debris out of the joint, which will allow it to, which will keep it from retaining moisture inside of the joint and allow it to dry properly, which will prevent corrosion at the joint. And this is especially important because while this is a very common place to have corrosion, but it's also a very difficult place to access and an extremely difficult thing to repair. So if you can keep those cleaned out, that will buy you a lot of extra time on your service life and prevent a lot of costly future repairs. Now, as with the maintenance tables, there's a few things that owners should not do. One of the common problems that we see in the field is adding weight to the truss, either by adding overlay or by attaching utilities to the truss. Now, this can, of course, when you add load to the truss, you're reducing its load carrying capacity. So that will need to be checked by an engineer to make certain that you have enough capacity to carry the loads that you see. Now, with these maintenance tools and suggestions, we're hoping to enable bridge owners to better maintain their bridges, which will increase the bridge's longevity and reduce costly future repairs. All right. So, any questions?